This meeting is being recorded.
So in the next section of Chapter 1, Section 1.2, we're going to review bonding. The structural theory of matter, as it's titled here, is interpreted through the bonds that form. Specifically with organic chemistry, we're going to be focusing on mainly covalent bonds. We'll see some ionic species here and there, but carbon atoms tend to form covalent bonds. And we'll look at specifically this term of isomer a lot more in depth than you probably have in your general chemistry courses, but you may have been introduced to this term of isomer, which is a compound or two compounds at least that have the same molecular formula. There can be three or four or many different orientations or bonding patterns with the same molecular formula. But this instance down here, we have what are called constitutional isomers. So they have the same molecular formula, but a different arrangement of atoms, a different bonding pattern. So we see, we have C2H6O for both of these molecules, but we'll definitely see this semester that dimethyl ether with a boiling point of negative 23 Celsius, and ethanol, which is an alcohol, has a much higher boiling point of 78.4 degrees Celsius. So things like boiling point and molecular interactions can change depending on the structure and the bonding pattern of molecules. So when we're forming Lewis structures for organic compounds, an important way to do this, or an important skill to have, rather, to be able to do this would be to identify the valency of different atoms. So we're going to see most commonly carbon atoms with bonds to nitrogen, oxygen, hydrogen, or halides, the halogens, right? So we have fluorine, chlorine, bromine, and iodine. So when we look at how we can put together these atoms, we want to recall that carbon generally forms 4 bonds, so it's what we call tetra for 4, tetravalent. Nitrogen, remember it usually has that lone pair here, likes to form 3 bonds when it's neutral, so that's trivalent. It has 3 valence electrons involved in bonds. And then we have our divalent with 2 lone pairs, oxygen here, that generally forms 2 bonds, right? So divalent and 2, this was 3. And then we have our monovalent species here, so things like hydrogen, or we generalize the halogens, in organic chemistry as an X. So anytime you see an X in a reaction, it could be a fluorine, chlorine, bromine, or iodine, depending on the reaction. Sometimes we'll only see chlorine and bromine, for example, that participate. So again, X is just a generalized term for a halogen, and those and hydrogen are both monovalent. So we'll use this information and these skills in some of the Chapter 1 practice problems when we are drawing Lewis structures and putting together these atoms from molecular formulas. All right, so that's everything with section 1.2. We'll continue with 1.3 with the next video.